solve a work problem. Two chefs are preparing a banquet. One chef could prepare the banquet in 2 hours less time than the other. Together, they complete the job in 5 hours. How long would it take the faster chef working alone? We want to write the answer to the nearest tenth. After reading the question, we want to assign variables here. So in this case, we can let X be the slow shift's time alone. So how long will it take for the slow shift to complete the job? So the fast shift's time would be X minus 2, because it works 2 hours faster. So we're going to make a chart here, make a little table. We write the rate and time together is 5, is given to us, and we also find a fractional part done. So the fractional of time that each of them would complete the job. So the rate is 1 over X, because we don't know the time for the slower chef, and the rate for the faster chef would be 1 over X minus 2 in terms of X. So the fraction of the time is done by the slower chef would be 5 over X, and the fraction of time is done by the faster chef would be 5 over X minus 2. If we put them together, 5 over X plus 5 over X minus 2, that should add up to 1, which is the whole job. So this is the equation that we need to solve for. A few things we want to make a note here. X cannot be equal to 0. Every time we see a variable at the bottom of the fraction, we want to make sure that the variable doesn't make any of them equal to 0. So we don't want to have an undefined part here. So X cannot be equal to 0. X minus 2 cannot be equal to 0. That means X cannot be equal to 2. So I'm going to make a note here. If I find X equal to 0 or 2, at the end solving this equation, I'm going to exclude them as part of my final answers. So let's take a look. What we need to do is find the LCD first. The LCD would be X times X minus 2. Then I have to multiply each term by that to eliminate the fraction. So let's look at the steps. If I multiply each term by LCD, the first term times X minus 2, X and X reduces to 1. So you would get 5 times X minus 2, which is right here. Now the second term, X minus 2 reduces to 1, and then you get X times 5. And the last term simply would have X times X minus 2. So by multiplying each term by LCD, we can reduce this equation into a linear equation where we can easily solve for that. Here, if I distribute 5 and X and write this in the standard form by adding the like terms, then I can factor this. Once I factor them, I can solve for X. Now, if it's not factorable, then we can always use quadratic formula. Let's review that quickly. The formula you need to remember, minus b plus and minus square root of b squared minus 4ac over 2a. You need to memorize this. Again, you can refer to my session on quadratic formula if you still have problem with this process. You identify the coefficients of x squared and coefficient of x and the constant. Those are my a, b, and c's, and substitute them into the equation and just solve for x. Here we go, minus times minus 12 give me 12. 12 squared minus 12 squared give me 144. When I multiply negative 4 times 1 times 10 give me minus 40. So what I get under the radical would be 104. So I get two answers, 12 plus square root of 104 over 2, or 12 minus square root of 104 over 2. For square root of 104, I can reduce that to 4 times 26. So 104 would be 4 times 26. So part of 104 is perfectly square. That 4 would come out as 2. So you get 12 plus or minus 2 radical 26 over 2. You notice that each of these terms are a factor of 2. So if I divide each term by 2, I can reduce them, or I can factor a 2 at the top of the fraction and reduce them with 2. So x would be 6 plus and minus radical 26. Now I can use my calculator to evaluate. I get x equal to 11.1 or 0.9. Now I have to see which one of these answer makes sense. The slow shift time cannot be 0.9 because the faster shift time would be negative. If I substitute that and subtract 2 from that, I get negative. That doesn't make sense. So the slow shift time working alone must be 11.1. If I subtract 2 from that, that would be the time for the faster shift.